Okay, we're going to get to the point where you guys can write your own proofs, but we're going to take some baby steps. So let's talk about what is a proof first. I have here that it's a set of statements and reasons that show that a fact is true. So we're not writing full proofs down here because you'll notice I only gave you information. I didn't tell you what to prove. We're just going to kind of do the first part of the proof here. Every single proof that we're going to write in two-column form needs to have this kind of T-chart shape. It needs to say statements at the top of the left column and reasons at the top of the right column. This is just a formality that we have to use in geometry. Okay, the very first step is almost always the given, so this one's the easiest step. I'm going to just rewrite what they wrote for me. So BD is perpendicular to AC. And the reason is that was given to us. Okay, so before I go any further, I'm going to take this information and draw it in the picture. So if BD is perpendicular to AC, that means that I have to have a right angle here and here. Okay, so now I'm just going to start writing what can I tell that is true from this statement that was given to us. So what I just wrote in the proof should help you here. I wrote that those two have to be a right angle. So I'm going to put angle BDA and angle BDC are right angles. Okay, and the reason that they're right angles is because that's it said that those two segments were perpendicular. So this is the definition of perpendicular. And I'm just going to write the symbol because perpendicular is a long word. Okay, since they're both right angles, I also know that they have to be congruent. So angle BDA is congruent to angle BDC, and the reason is that all right angles are congruent. That was a theorem that we learned way back in the day. Okay, and that's all that I can tell from the given information. I don't know what they wanted me to prove. These look like congruent triangle proofs, but there's nothing I needed to prove. Let's try the next one. If it says DB bisects angle ABC, remember bisect means to cut, that's sect, and bi is two, so to cut into two equal pieces. So DB is cutting angle ABC, this angle up top, into two equal pieces. So if I drew that in the picture, it would look like this. What if I put two arcs up here? So let's write this down. My first step, rewrite the given information. DB bisects angle ABC. Okay, then number 2 is going to be what I marked in the picture. So angle ABD is congruent to angle CBD. Now, if there's ever a word in your given information, your next step is almost always, not all the time, but almost all the time, going to be the definition of that word. Definition of bisect. Because bisect means to cut it into two equal pieces. So here's the two equal pieces. That's all we can tell from that given information. Let's try the next page. So number 3, it says C is the midpoint of AE. So if C is the midpoint of AE, that means it's right in the middle. That means that this part and this part have to be equal to each other. So number 1, we're going to rewrite what they told us. C is the midpoint of AE. I also want you to notice how I put a number 1 over here and a number 1 over here. A lot of times, especially if you have messy handwriting, it's not easy to tell which statement goes with which reason, so it's a good idea to number them so I know step 1 goes with reason 1. Okay, so if it's the midpoint, midpoint's a word, I bet this is going to be the definition of midpoint. Okay, so what does it mean for it to be the midpoint? C's got to be right in the middle. Those two parts on either side have to be the same. So AC is congruent to CE. And that's all we can tell from that one. Okay, the next one we have AE bisects BD. So we bisected before, but it was an angle. So let's look at this one. AE, that's this one, bisects BD. So this is cutting this segment into two equal pieces. So that means those two are the same. So let's start by rewriting the given information. AE bisects BD. Okay, so once again, there's a word in the given information, so I'm probably going to define that word here. So we marked on the picture that BC is congruent to CD. And that's all we can verify from that. Then the next one, we have PQ is perpendicular to QS. So if PQ is perpendicular to QS, PQ is perpendicular to QS, that means that has to be a right angle. Okay, also in the given information they said TS is perpendicular to SQ. So here TS is perpendicular to SQ means that this has to be a right angle. Okay, so then let's go back and write what we just wrote down. We put that angle Q and angle S are right angles. That would be the definition of perpendicular. And then because they are both right angles, they have to be congruent. Because all right angles are congruent. Okay, so we just went through, oh, there's a few more. Let's go back to the page before. We wrote down everything that we could verify with the given information, but we have in this picture, there's something else we can tell. I'm going to put it in a different color because it's not from the given information, it's from just the figure. This has the reflexive property in it because both of the triangles share side BD. So I can also put side BD is congruent to side BD by the reflexive property. Okay, and then the same thing for number 2. It's the same picture, so we can put BD is congruent to BD by the reflexive property. Okay, let's see if there's anything else we can mark from this one. All of the pictures on this side look like a bow tie, so we're going to be able to put some vertical angles. So let's do angle ACB is congruent to angle ECD because vertical angles are congruent. Same here, same picture. Angle ACB, angle ECD. Vertical angles are congruent. And down here it's a different picture, so we're going to have different letters here. Let's try angle PRQ is congruent to angle SRT. Vertical angles are congruent. Okay, let's try the next page. So for this one, it says angle A is congruent to angle C, so marking that in the picture looks like that. As you can see, I wrote down the statements and reasons for each of these to save us some time. I copied the given information into the proof. This one's tough. From what we've drawn, it's not obvious that there's anything else congruent, but if you ignore this middle line down the center, and I asked you what kind of triangle this is, it's got two equal angles, so I know that it also has two equal sides. So that next step is going to be side AB is congruent to side BC, and this is the converse of the base angles theorem, or the isosceles base angles theorem. If you said base angles, I'd know what you're talking about. Converse of isosceles base angles theorem. That says basically if a triangle has two angles the same, it has to have two sides the same. Okay, so that's the only thing you can tell from the given information, but once again, this picture has the reflexive property in it. Both triangles share side BD, so you can put BD is congruent to BD by the reflexive property. And that's all we can do for that one. The next one is a little more complicated. BD is the perpendicular bisector of AC. There's two different things going on here. So let's deal with perpendicular. It's first saying that BD is perpendicular to AC. So if BD perpendicular to AC means that that's a right angle, which means it has to be a right angle on the other side as well. Then the bisector means that BD is cutting AC into two equal parts. So I can mark that those two are the same. Okay, so let's deal with perpendicular first. We said angle BDA is congruent to angle, oops, no, it does not say that, and angle BDC are right angles. That would be the definition of perpendicular. Number 3, we can say that those two angles are the same. Because all right angles are congruent. Okay, then let's deal with the bisector. Number 4, we put that segment AD is congruent to segment CD because of the definition of bisector. And that's all we can tell from the given information. We can also tell from just the figure that side BD is congruent to side BD by the reflexive property. Okay, last one. This one says AB is congruent to CB. AB is congruent to CB. Wrote it in the problem already. This is once again an isosceles triangle if you ignore the middle line. So if it's an isosceles triangle, it also has to have two congruent base angles. So angle A is congruent to angle C. The reason would be two sides of a triangle are congruent, then its base angles are congruent. That is the isosceles base angle theorem. Okay, that's all we can tell from the given information. So by just looking at the figure, I know that side BD has to be congruent to side BD. That is the reflexive property. Okay, in this notes, we weren't so much worried about what we needed to prove as how much could we write down that we know based on the information that they gave us. What sort of conclusions can we draw from the information they gave us? Okay, so the next step is going to be to start writing some proofs.